In previous videos, you have learned how to solve a system of equations with both the graphic method and the substitution method, both of which are good but have limitations. And the primary limitation is going to be with coefficients bigger than 1. So if you had like 2x plus 4y or 3x minus 7y, it's going to be difficult to use the substitution method because you're going to have fractions. So this method is particularly useful when you have coefficients bigger than 1. Now this first example does have coefficients of 1, but this process can be used for any coefficient. So here we see x plus y equals 4 and negative 2x minus y equals 3. So the idea is once you have your two equations, you can either add or subtract them together to get one of the variables to cancel. So notice we have a positive 1y and a negative 1y. If I add the equations together, we would now have those canceling out, right? Y plus negative y would cancel, so those are gone, and we're left with just x's. So 1x plus negative 2x would give me negative 1x. And then on the right side, 4 plus 3 gives me 7. So notice the y's are gone. We have just x left over. And now just need to get rid of the negative with the x. And if negative x is positive 7, then positive x is negative 7. So I've already solved for one variable. X is negative 7. And then to finish off, I plug negative 7 back into either equation, does not matter which one, and then I can find my y. So this first equation will be easier because notice when I plug in for x, there's no coefficient, whereas the second equation there is one, which makes it sometimes a little more difficult. So plugging a negative 7 in for x in the first equation, I now have negative 7 plus y equals 4. And then solve for y by adding 7 to both sides. When I do that, I now have y on the left side and then 11 on the right side. So my solution is x equals 7 and x is negative 7, y is equal to 11, which I can write as an ordered pair, negative 7 comma 11. Because remember what we're doing is with these equations, we're trying to see where they intersect. So if you were to graph these, we graph like this, all right, and we see that they would intersect right here at this point, which is negative 7, 11. So instead of having to graph both equations, I can just solve by using this method to determine where they intersect. So not only could I add the equations together, but I can also subtract equations together. So here we have our two equations. And notice in this case, the coefficients are all bigger than 1. So this subtraction method or addition method is going to be easier to use than the substitution method because here we're not going to end up with as many fractions. All right, so notice the two y's. Both equations have a 2y. So if I subtract the equations, then the 2y minus 2y would cancel. And I'm left with 3x minus 4x, which is negative 1x. And be careful because we're doing 6 minus negative 3, which is a positive 9. So negative x equals a positive 9. So if negative x is positive 9, then positive x would equal negative 9. So I have solved for x, and now I just need to solve for y. So what I do is I plug negative 9 into either equation, doesn't matter which one. We'll pick the first one just because. So we have 3x plus 2y equals 6. Plug negative 9 right here in place of x. I now have 3 times negative 9 plus 2y equals 6. 3 times negative 9 is negative 27. And then from here, I can solve by adding 27 to both sides. That's a 27 over there. So we have 2y equals 6 plus 27, which is 33. And then I can divide both sides by 2. we now have y equals 33 over 2, which is 16.5. So my solution is negative 9 comma 16.5. And what we found is that if we were to graph these two equations, they would intersect right here at this point, negative 9 comma 16.5. And notice this would have been very difficult to do by graphing, because we would not know for sure if it's crossing right in the middle in between 16 and 17. So this method has advantages for sure, and if I were to choose just one method to know how to solve, it would be using this addition or subtraction method. And that concludes our lesson for today. We will see you next time.